let's learn the permutation and combination basics in easiest way. Start with order and position. Here, the letter A is in first position, B is in second position, C is in third position. And this is a order of 3 letters. When any 2 letters change their position, new order created. This is a new order of 3 letters. So we can say every change of position create a new order. Order is the arrangement of things in relation to each other according to a particular sequence or pattern. Now let's learn select and arrange. Suppose we have 4 digits 1, 2, 3 and 4, and we want to select any 3 from these 4 digits. In this case, we have to take 3 digits out of these 4 digits. We can choose 1, 2, 3 or any 3 digits from these 4 digits. In selection, we choose the alternatives, or we can choose 1, 3, 4. In this way, we can select any 3 digits from these 4 digits. If we want to select 2 digits, that case we have to choose any 2 digits from these 4 digits. Suppose we have 3 digits 1, 2 and 3, and we want to arrange these digits. To easily identify the new arrangement, let's give the position of these digits. The position of 1 is first position, the position of 2 is second position, and position of 3 is in third position. This is the arrangement of 3 digits 1, 2, 3. If any 2 or 3 digits change their position, new arrangement created. That is 2, 1, 3. This is a new arrangement of 3 digits. Similarly, 2, 3, 1. This is also a new arrangement of 3 digits. Selection and the arrangement is the backbone of permutation and combination. Now, the concept of factorial. The factorial of a positive number n is the product of all integers less than or equal to n. And the factorial n is denoted by this notation, n factorial. For example, 5 factorial equal to 5 into 4 into 3 into 2 into 1. That is from 5 to 1, the multiplication of all integers. And 2 factorial equal to 2 into 1. So we can write n factorial equal n and 1 less from the previous n, that is n minus 1, n minus 2, n minus 3 and finally up to 1. The multiplication of this number we can write as n factorial. Is it possible to find 0 factorial? Yes, possible. Let's see how. We can write 7 factorial equal to 7 into 6 into 5 into 4 into 3 into 2 into 1. That is from 7 to 1, multiplication of all integers. And look carefully. From 6 to 1, this multiplication value we can write as 6 factorial. So we can write 7 factorial equal to 7 into 6 factorial. And if we write it another way, that is 7 factorial equal 7 into, for 6 we can write 7 minus 1, that is 7 minus 1 factorial. If we substitute n in place of 7, we can write n factorial equal n into n minus 1 factorial. If we want to verify this one, let's see. N factorial equal to n into n minus 1 into n minus 2 into n minus 3 and the multiplication up to the integer 1. You see here from n minus 1 to 1, this multiplication value we can write as n minus 1. So we can easily write n factorial equal to n into n minus 1 factorial. After the simplification, we can write n minus 1 factorial equal to n factorial divided by n. and if we substitute the value n equal to 1, then we have 1 minus 1 factorial equal to 1 factorial divided by 1. We can easily say 1 factorial equal to 1. And after simplification, we get 0 factorial equal to 1 divided by 1, that is 1. So this is our value, 0 factorial equal to 1. Now, AND or rules. Suppose there are 3 places, place 1, place 2 and place 3. The place 1 and place 2 connected with 3 paths, that is P1, P2 and P3. And place 2 and place 3 is connected with 2 paths, that is R1 and R2. How many ways we can choose to reach from place 1 to place 3? Let's see the alternative paths. We can choose P1 to reach from place 1 to place 2 and R1 from place 2 to place 3, that is P1 R1. In another path, we can choose P1 to reach from place 1 to place 2 and we can choose path R2 to reach from place 2 to place 3. Again, we can choose P2 R1, P2 R2, P3 R1 and P3 R2. So we can reach from place 1 to place 3 using these 6 paths. Let's counting all the alternative paths to reach from place 1 to place 3. The first path is P1 R1. The second path is P1 R2. We can use P1 R1 or P1 R2. So first path or second path, the counting is 2. Or we can use P2 R2. So counting is 3. Or we can use P2 R2. We have 4 alternatives. We can use P3 R1. We have 5 alternatives. And finally we can use P3 R2. So we have 6 alternatives. So when we use OR, we add all the alternatives. So OR indicate the addition. Let's use another method to finding the total paths. Here, first we have 3 ways to reach place 1 to place 2 and 2 ways to reach place 2 to place 3. So we have 3 way and 2 way. So 3 way into 2 way, total 6 way. So when we use AND, we multiply the alternatives. So we can say AND indicate multiplication. How many ways the digit 1, 2 and 3 can arrange? We have 1, 2 and 3. To arrange these 3, we have 3 positions. That is first position, second position and third position. The first position, we can fill up this first position with 1, 2 or 3. So for first position, we have 3 alternatives. Suppose we fill the first position with any of these digits. So for the second position, we have 2 alternatives. We can use 2 or we can use 3. So for the second position, we have 2 alternatives. Or we can say 2 options to fill the second position. If we fill up this second position with any of this number, and for the third position, we have only 1. That is 1 option to fill the third position. For the first position, we have 3 options. For the second position, we have 2 options. And for the third position, we have 1 option. So we have to fill first position and second position and third position to arrange the numbers. Try to remember the AND rules. AND means multiplication. So we have 3 into 2 into 1, that is 6 arrangement, because this AND means multiplication. Let's verify it. If we arrange the digit 1, 2 and 3, we will get 6 arrangement. 1, 2, 3, 4, 5 and 6, and we will get 6 arrangement. If we have n different things from which r number of things we want to arrange, how many ways we can arrange? we have n different things. From this n, we want to arrange r things. To arrange these r things, we need r places. Suppose n different things is labeled with this number, that is n, n minus 1, n minus 2, 3, 2 and 1. So these number indicate n different things. To get the arrangement, we have to arrange r position. Let's start with first position. For this first position, we have n alternatives. How? Let's see. We can fill this first position with this n or n minus 1 or n minus 2, or we can use this 3, 2 and finally 1. So for this first position, we have n option to fill this position. In this way, we have to fill r position, that is second position, third position. And suppose the first position is filled up with n. So how many options we have left for this second position? This is n minus 1, n minus 2 and up to 3 to 1. So we can fill this second position with n minus 1, n minus 2 and in this way 3, 2 and finally 1. So for second position, we have n minus 1 option. And if we fill the second position, suppose with n minus 1, in this way, for the third position, we have this number n minus 2 and up to 3, 2 and 1. So we can say for first position, we have n options. For the second position, we have n minus 1 options. For the third position, we have n minus 2 options. And now, what will be the value for the rth position? Look at this value. This value is always 1 less from the position. That is, for the second position, the value is 1. That is n minus 1. So for the second position, we have n minus 1 option. For the third position, we have n minus 2 option. So we can say the value will be n minus 1 less for the position, that is n minus r minus 1. Since we have to fill the rth position, so the number will be n minus r minus 1. This number is always 1 less from the position. Here the position is r, so the number will be n minus r minus 1. So we have n minus r minus 1 options to fill the rth position. And try to remember the n rules. We have n option, n minus 1 option, n minus 2 option and up to this n minus r minus 1 option. So first position we have n option, for second position we have n minus 1 option, for third position we have n minus 2 option and for rth position we have n minus r minus 1 option. Finally, we get result when we multiply all these options. So n into n minus 1, n minus 2 and up to n minus r minus 1. This n into n minus 1, n minus 2 and up to n minus r minus 1 gives the value for the arrangement. That is, we can arrange in these ways. If we arrange r things which are taken from n different things, that case we will get this way. That is n into n minus 1 into n minus 2 and into up to n minus r minus 1. We want to simplify it. For this, we multiply with n minus r factorial and divide with the same value n minus r factorial. Here, the value of n minus r factorial is the multiplication value of 1, 2, 3 and up to n minus r. If we substitute the value of n minus r in numerator, we can write the whole value as n factorial. So we can write n factorial divided by n minus r factorial. So this is the simplified value. This value is denoted by this notation. This is the first formula for permutation. If we have n different things from which r number of things we want to arrange, how many ways we can arrange? The value is npr, that is n factorial divided by n minus r factorial.